Yes, sir.
This meeting is being recorded.
Well, today's topic is refraction of light through a glass slab. Refraction of light through a rectangular glass slab. Here I will suggest draw all the diagram. This has only one using scale and pencil. Now suppose I have a glass slab rectangular PQRS, right? Now at array at point B. So at point B, array enters the glass slab. So we'll have to draw a normal MBM dash. Right? Okay. Now this is the ray entering the glass slab at B. Say the name of ray, this ray is AB. So this is incident ray. Now tell me, had the glass not been there, right? It would have gone straight. It would have gone straight like this. Now, since the glass slab is there and this is air, right? And this is glass. So, the light entering from a rarer medium to a denser medium. So, it will bend towards the normal. Now, this is your angle of incidence. This is your angle of refraction, right? Now it is again hitting the face QR of the glass slab. So I have to draw again a normal here. Say this is hitting at point C and I have taken mm dash, so I'll take nm dash. Right? It has been observed that this ray, which is known as emergent ray, A, B, C, D. Now, if I observe, or if experimentally, we'll write certain things. Wait. Number one, a light ray traveling in air strikes the face PS of glass slab at B. We can write in brackets incident ray AB. Number two, when ray AB enters the glass, it bends towards the normal as refracted ray So this is your refracted ray. As refracted ray BC, which again strikes the face QR of glass slab. Number three, now BC travels from glass that is denser to air which is rarer, and hence it bends away from the normal. Number four, which is very important. From experimental verification, it has been observed that emergent ray CD is parallel to the original path of light, original path of light. Don't write anything right now, right? original path of light, that is path of incident ray AB. Okay, now let me explain. See, this is air, rarer medium. This is, now I can write it here, glass, denser medium. Now when ray AB strikes the glass slab face PS at B, it will bend towards the normal because it is traveling from rarer to denser. The refracted ray BC again strikes the face QR of the glass slab. Now this time on this at this end also it is air. Now again the glass the refracted ray is traveling from denser to rarer medium. Now as a result, the emergent ray, this is called emergent ray, CD. Emergent ray, right, bends away from the normal. Now we have experimentally found this, that this line AB or BR, AR is parallel to CD. But it is shifted. If I draw the perpendicular distance, say this is E. Last point, the emergent ray CD has or is parallel to AB, but it shifts shifts laterally from original path of incident light or incident ray. Point number 6, CE, this distance, perpendicular distance, C, the perpendicular distance between AR and CD is called lateral shift. Is called lateral shift. Bojutjo,
Yes, sir.
have you understood what happens?
Yes, sir.
See, this AB is the incident ray.
Yes.
Okay. If I write B here, AB is the incident ray, right?
Yes, sir.
Now suppose the glass slab is not here. So it will continue to move in straight line.
Yes, sir.
This is the original path
Yes, sir.
of the light. But since the glass slab has been put PQRS and the light is moving from rarer to denser, so it will bend towards the normal, which is mm dash.
Yes, sir.
It bends towards the normal and again it strikes on face QR at C. Now here the refracted ray becomes incident ray again.
Yes, sir.
Clear?
Yes, sir.
The refracted ray becomes incident ray again. Now
Yes.
situation is reversed. It is traveling from denser to rarer medium. Clear?
Okay, sir.
Now you can see this angle and this angle are equal. This is also R,
Okay, sir.
right?
Yes, sir.
This is also R.
Acha.
Now
Yeah.
this angle is known as angle of emergence. You can write here E is known as angle of emergence.
Yes, sir.
Right? Now it has been experimentally found that the original path of light is parallel to the emergent path of the light. But
Okay.
it is shifted a bit. So if I find the parallel, the perpendicular distance between two lines, that is known, C is known as lateral shift.
The C, the point C.
CE, this distance is known as lateral shift. It shifted, the light ray shifted from here to here. No?
Yes, sir. Understood.
Finally, the light ray shifted from the path of ER to path of CD.
Yes, sir.
These are parallel. Experimentally, we have verified this. All scientists have already verified this. But there is a shift. Pratyasha,
Yes, sir.
have you understood everything?
Yes,
Or
sir.
shall I explain once again?
No, sir, I understand.
Now tell me what is happening. If you have understood.
Yes, sir. Sir, first of all, light ray is
Which light ray?
the incident.
Names are written. Names are written, beta. Name the ray.
Sir, AB.
AB. Strikes.
AB is striking the ray at point B.
Striking the glass slab.
Glass
Face
slab
of,
point B.
face PS of glass slab at B.
B.
Now since it is traveling from rarer to denser, the refracted ray bends towards the normal. Clear?
Yes.
And the refracted ray hits the phase QR,
At
the
point C.
second phase QR at C. Now this refracted ray is actually acting another incident ray,
Yes.
right? And finally, CD is the emergent ray, right? But here it is traveling from denser to rarer, so it will be
Move away
away
from.
from the normal. Experimentally, it has been found that the original path is parallel to the emergent path. But there is a shift between them, and the perpendicular distance between these two parallel lines is known as shift, lateral shift.
Yes.
This will not happen in Prism. The next topic is Prism. Draw this diagram neatly using pen and scale.
Sir, copy.
Me too, sir. Copied, sir.
Now prism. Basically, a prism is a transparent medium bounded by 5 surfaces. Can you count? One, two, front one, three, back one, four, and the base. So I can name it as A, B, C, and A dash, B dash, C dash. A prism is a transparent medium bounded by 5 surfaces having a triangular cross section, right? See, this is 3D view. This is three-dimensional view. And symbolically, we'll be using just like this.
Copy, sir.
One second. So done.
Hmm. Refraction of light through a glass prism. As I told you, I will not be making a three-dimensional diagram of prism while drawing the ray diagrams. Now suppose we have a prism A, B, C. Okay.
Yes, sir.
Now at this point, right? Say this point is Q. I may write the point later. Let me draw a normal first. Right? And this normal is NM. Clear? Now suppose a ray PQ. Right? Now this material is glass. And here it is air. So it is entering from air to glass. So it will bend towards the normal. It's not looking nice. Let me make it more. Yeah. So it bends towards the normal, and again at point is R. It hits the face AC of the prism. So we'll have to draw another normal here also. And we'll call it NM dash. Now, this becomes this is your angle of incidence. This is your angle of refraction, right? Again, this ray QR acts as a incident ray. So, since it is this way is this side is also air, so this bends away from the normal, and it goes like this. Now, can you see? This was the original path of the light or not? Had the prism not been there, it would have traveled in the direction of PQ. Yes, Pratyasha, Boidujo. Don't behave like a dump. What is the original path of the light? Am I audible?
Yes, sir.
What is the original path of the light? PQ?
Yes, sir.
Remove the prism. It would have gone in this way, na?
Yes, sir.
But since the prism is there, the light ray will bend towards. So this QR, PQ is incident ray. QR is refracted ray. And say this is S. RS is the emergent ray. Right? Now this is the original path, say PQT. And this is the final path. Am I right?
Yes, sir.
Yes, boy, Durjo.
Yes, sir.
You are not sounding confident, but comfortable.
Sir, PQ is the original path you said, and N and M dash. Which
These are
one
two
is the
normals. These are two normals.
Okay, sir.
So it will bend towards the normal.
Yes,
So
sir.
Q1 becomes a refracted ray.
Yes, sir. Oh, okay.
If there were no prism, then it would have traveled in this direction. Am I right?
Yes, sir.
So we can assume that this is the original path.
Yes, sir.
Now, what is the final path? Can you name what is the final path?
Sir, RS.
RS. Good. This is also known as emergent ray. Here.
Yes, sir.
And this is known as angle of emergence. Now, if I produce the final path backward, can you see this much angle? This much angle, the light deviated from its own path. So this is called angle of deviation. Okay.
Okay, sir.
Now we will write 2-3 points. Let us take a glass prism ABC as shown in the adjacent figure. Right? Number 2, a ray PQ of light within brackets incident ray strikes the face AB of prism at Q, and it bends towards the normal as light is traveling from rarer to denser medium. This ray QR is called refracted ray, right? Point number 3, the refracted ray QR strikes the face AC of the prism at R, and it bends away from normal as now light is traveling from denser to rarer medium, right? Now let's name this point also. TU. Point number 4, the angle TUS between the wait a minute, and emerges out as ray RS called emergent ray. The angle TUS between the original path incident ray and the final path emergent ray is called angle of deviation. Now here I would like to discuss one thing. If you remember the glass slab case, right? I'm drawing it roughly. The glass slab case, it bent. So light is not deviated from its path. Light is along or parallel. There is no deviation. The angle between two parallel lines is zero, na?
Yes, sir.
Yes, sir.
So light has not deviated, but here the light has deviated by this angle. Had the prism not been here, it would have gone P to Q to U to T. Am I right?
Yes, sir.
Now since the prism is here, it gets refracted once here and again refracted here. So this is the final path. This is the final path or not?
Yes, sir.
And this is the original path.
Yes, sir.
Now if we produce back PQ, I have to produce forward and RS I have to produce back. So this much angle, the light got deviated.
Sir.
That is why this is known as angle of deviation, and this angle is called angle of prism. It is not given in your book. Generally, we denote it by A only because we take always prism as ABC.
Sir,
Hmm.
do we always calculate the angle of deviation with the final path of light?
Of course, we have to.
Not the
No,
medium
no, no,
like.
no, 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 no. Because the has not finished here. It is
Okay.
again emerging out now.
Yes, sir.
So this is the original ray, this is the final ray. Can I say that? This one
Yes,
is the
sir.
original ray, this is the final ray.
Yes, sir. Yes, sir.
Now it will not bend anymore, no? Till the time further refraction happens.
Okay, sir.
Ideally, I have taken entire this area is there. So it will go in straight line,
Yes, sir.
right? It would have also gone in straight line had the prism not been there.
Okay, sir. Understand.
Am I clear?
Yes, sir.
Yes, sir.
So that is why I have produced forward the incident ray PQ, right? You should write all this incident ray, this is refracted ray, and this is written emergent ray. I'll be back from washroom in a minute.
So copy.
I'm back.
Completed, sir. Sir,
Yeah,
you have drawn a small structure beside angle of prism with an equal to sign. What is that?
that is parallel line.
Sir, what are you trying to show by it in this case?
अरे यार, angle between parallel lines is zero. That means the light had not deviated in case of the light. These two lines I have redrawn here,
Oh,
right?
yes,
The
sir.
light has not deviated. Deviation will always be an angle, and we know the angle between two parallel lines or two anti-parallel lines is zero.
Yes, sir.
Clear? So that
Yes.
is what I was trying to
Okay,
explain.
sir.
Here that is not the case. Here there is an angle of deviation. Is
Okay,
that
sir.
clear?
Yes, sir.
Dispersion of light by a prism discovered by Newton. What he did, Newton took a prism like this, ABC. Okay. And from a small hole, he allowed a ray of white light, say this is ABC, a ray of, this is an incident ray of white light. He found a very interesting thing, that the prism separates them splits them into 7 constituent colors. And then he also took a screen. He also took a screen and by further refraction of light, he obtained exactly V I B G Y O R. Now, what is dispersion? The splitting of white light into its 7 constituent colors by a prism is called dispersion. Now, the question is, what is happening at phase AC? Nothing, only refraction is taking place here. Here, it is dispersion. Now, what is the cause of dispersion? Cause of dispersion? See, refractive index mu is equal to sin I by sin R. We also know that this is equal to speed of light in air by speed of light in medium. Have we understood up to this?
Yes, sir.
Yes, sir.
Now, what will be the value of sin r from here? Sin r will be equal to sin I into speed of light in medium. I am just doing the cross multiplication divided by speed of light in air. Clear?
Yes, sir.
Now, we know speed of light in air is a constant. So we can write sin I into speed of light in medium by, we denote it by C. Remember? Hello.
It's the speed of light in air.
Hmm. It is denoted by C, which is constant.
Okay, sir.
Now, if I keep the angle of incidence constant, say 45 degree, right? So sin I will be 1 by root 2 or not? I can keep it constant, huh? Hey, don't behave like dumps. Pratyasha,
Yes, sir.
can the angle of incidence be kept constant? Yeah, if I don't turn it, I have allowed this much space and at this angle. So that means my angle of incidence is constant or not.
Yes, sir, constant.
If I don't rotate, Buljurjo, are you understanding?
Yes, sir.
If I don't rotate the incident ray, the angle of incidence will not change. Huh?
No, sir.
Therefore, what will happen? C constant, sin I constant. If I is constant, sin I will be constant or not.
Yes,
Yes.
sir.
That means angle of refraction, or you can say sin R will depend on speed of light, speed of light. See, this is point number 1. If angle of incidence is kept constant, then sin R will depend on speed of light in medium. or we can say sin r is proportional to speed of light in medium. Can I say that?
Yes, sir.
Boydurjo, have you understood this point? Last point.
Yes, sir. If angle of
Why
incidence is
sin r is proportional to speed of light? Explain me.
if angle of incidence is kept constant, then sin r will depend on
Boydurjo, don't speak in a murmuring voice. Speak loudly. I cannot hear you.
yes, sir. Sin r will be proportional to speed of light in medium. Since sin I and the angle of incidence is kept constant, so sin r can only change if the speed of light in
Arey
medium changes.
yaar, angle of incidence is constant and speed of light in air is also constant.
Yes, sir.
So if these two are constant, then sin r will depend on speed of light in medium.
Yes, sir.
Therefore, sin r is proportional to medium, speed of light in medium.
Yes,
Now
sir.
here there is a catch. Since the speed of light of different colors is different in a given medium. Like such as such as wait a minute. Since the speed of light, different colors is different in a given medium. Hmm, Acha, first of all, here there is a stark mark. Prism does not produce any color. Since the speed of light of different color is different in a given medium, therefore, 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 refractive index, refractive index mu will also be different for different colors like mu for violet. Mu for violet is maximum. And mu for red is minimum. Right? We will end it. Write down up to this. Don't write unnecessary things.
Sir,
Yeah.
sir, I wrote this one, and by the point number 2, did you mean that if the angle of incidence is kept constant and the speed of light in air is kept constant, then the sign R will only change when the speed of light in medium is changed or so?
Yeah. That is the thing.
Okay, sir. And sir, what do you mean by prism does not produce any color? Like the in the star, prism does not produce any color.
See, see, white light contains these 7 colors.
Yes, sir.
The job of the prism is to split them
Okay,
because
sir.
of these reasons.
Okay, sir.
Prism itself does not produce any color.
Oh, okay, sir.
Now
Sir,
suppose,
then,
wait.
yes, sir.
In place of white light, if I send only a blue light, pure blue light, you think you are going to get a Vibjar? No,
No, sir.
because dispersion will not take place and prism does not produce on its own any color.
Yes, sir.
So you will get only a blue light. Only
Okay,
this
sir.
line will be there.
Sir, sir, I was saying that you are producing just one white light here. So if we produce a multiple white light?
Multiple white light means?
Means, for example, the light is coming from the sun. Then
Hmm.
not a single ray, but there are multiple rays.
So,
So in that case, the
see, a collection of rays known as what?
light.
No, a collection of rays known as beam. Clear?
Yes, sir.
So the thicker will be the ray, the thicker will be the spectrum. This is known as spectrum. The band of color obtained. We'll write, just finish this. The band of color obtained, you write here screen. The band of color obtained on the screen is called spectrum.
Sir,
Yeah.
is prism the only thing capable of causing dispersion in white light?
No. Even rain droplets, they cause,
Yes, sir.
right? And
Yes, sir.
because of what? We see the Vibjar in rainbow.
Yes, sir. Yes, sir. I know that. So, um, that is how white light will get dispersed. Like when dispersion is caused, then the spectrum is obtained.
See, first of all, hang on. Dispersion is not possible by any other shape. It has to be a prism only.
Okay, sir.
close to prism.
Yes, sir. Okay, understood, sir. Thank you.
Now you can say the water droplet will be spherical. Am I right?
Yes, sir.
A drop is like a sphere, na?
Yes, sir.
So if you take a part of a sphere, suppose this
Yes.
is a droplet, we are going out of the way. Suppose this is a droplet. If I take a very small part of this, don't you
Okay.
think it is a straight line? If I draw a big droplet, the small part of it will be a straight line or not.
Yes, sir.
So now I'm writing AB here.
Yes, sir.
Okay.
Yes, sir.
So it's almost like a prism. So it will disperse.
Okay, sir.
Clear?
Yes, sir. Clear. Copied, sir. Copied.
What is going on in light in school?
Sir, they started heat transfer.
So Tasha was telling me that they are still on light.
No, they have
Started again.
advanced.
Hmm?
So they didn't even complete the chapter fully. I mean, not properly.
Sir, on Thursdays I was absent, and when I came back, they started heat transfer. So I cannot say.
The school started heat transfer.
What is in
Yes.
your section, Tasha?
The heat transfer is going on.
But you sent me a message on
It was
which
before
day?
Thursday.
I think yesterday only, no?
No, sir.
Hmm?
No, sir. It was September 22. On 23rd, they started heat transfer.
Acha. And today is 24th.
Yes, sir.
Yesterday they started heat transfer.
No, sir. Day before yesterday. On Thursday. Yesterday I
Sir,
was.
Acha, acha, acha. This message is at in the morning. Okay. So you also could not understand, Pratyasha, how they finished?
No, sir.
Have they discussed all this in such a length?
No, sir.
no, sir, not at all. Sir,
Hmm.
sir, one thing though, in my book, the date of when he.
First of all, Boydudjo,
Yes, sir.
come closer to the mic.
Yes, sir.
Now speak.
Sir, I was saying that in my book, the date when heat transfer was started is marked as 15/9/22.
Hmm.
That means sir started the chapter on 15.
Hmm.
But Pratasha is saying that it was started on 22.
Why we are beating behind the bush?
Sir, mm,
Can we do something on that? The classes taken in the school, is it under my control or your control?
sir, no one's control.
No one. So let's forget about that.
Yes, sir.
Let the puja vacation begin. They will be behind me.
Yes, sir.
Beta, this is your basics of light.
Yes, sir.
If you don't understand here, this light will become very, very difficult.
Yes,
You
sir.
have light in 9 also, you have light in 10 also. Then you don't have light in 11.
We don't have.
Then you have light in class 12, which I have told you already. That in class 12 we will be studying two types of light, two natures of light. Okay.
Yes, sir.
Now, in continuation to point 3, since you have noted, I am going to wipe off this. And I am putting a star mark here and continue from here. Right? Therefore, different colors of light get separated at face AB of the prism and on face AC of the prism, they get separated further because again refraction happens further due to refraction. Right? Now we have spectrum, something called spectrum. A band of 7 constituent colors of white light dispersed by a prism and obtained on screen is called spectrum.
Sir,
Yeah,
sir, one thing I'm just asking that is the name of the learning center named after this
I
spectrum?
cannot hear a single word.
Sir, I am saying that the name Spectrum Learning Center is the spectrum named after here.
See, spectrum means band of light.
Yes, sir.
And selection of the name was just a coincidence.
Oh, okay, sir.
Since I liked it, so I put it in that way.
Okay, sir. Thank you, sir, very much.
So done.
Me too, sir.
Done?
Yes, sir.
Give me 2 minutes. See, consequences, consequence, not sense, of dispersion in nature. In rainy season, sometimes after the rains, after the rains, we see big and beautiful arcs of the 7 constituent colors of white light coming from the sun. This is called rainbow. In formation of rainbow, the tiny droplets of water suspended in air act like prism and due to dispersion by these droplets, rainbow is formed. Recombination of light. White light. This I am not going to draw the diagram. It is given on the page number 88. See, this was also performed by Newton. He took a disk, right, and made a hole at the center of disk. And this disk was painted into 7 segments. 1, 2, 3, 4, 5, 6, 7. Right? And this was the axis of the disk. When it was rotated, it appeared to be totally white.
Sir, you know I have still not seen a rainbow in my life.
How do I know?
No, sir, you are not supposed to know. I'm just telling.
How do I know? You are asking a funny question. If someone comes to me and says that I have not seen my homework copy since long, how do I know? And what I am supposed to do by knowing that?
Sir,
But
nothing, sir.
rainbows are visible in North Calcutta. I have seen many rainbows while staying in Baranagar.
I don't know why, but I've never seen one.
See, rainbows are also formed near big falls. What
Big fall.
happens? Yeah, like Niagara Fall. Have you heard of Niagara Fall?
Yes, sir, we read in geography.
So when the water hits the stone at the lowest point, okay,
Yes,
it
sir.
splits the water into very small, tiny droplets.
Okay,
Now,
sir.
suppose sunlight falls on those droplets, there is again a formation of rainbow.
Oh, okay, sir. Copy it, sir. So.
Boydurjo, write in the group because we will be ending today now. To start with,
Yes, sir.
within bolts mensuration tomorrow.
Mensuration.
Mensuration should be within bolts.
Start with mensuration. Yes, sir. After that,
Followed by
followed by
spherical mirrors.
spherical mirror. Spherical mirror will be in bold, sir.
Yeah.
Spherical mirror. Tomorrow.
Acha, let me ask Pratyasha first. Pratyasha,
Yes, sir.
beta, have you completed the construction chapter?
Sir.
I'm talking about exercise 14.1 and 14.2.
Yes, sir.
All complete?
Yes, sir.
No doubts?
No, sir.
No, you will have to answer in the group so that your mother also sees.
Yes, sir.
I'm going to write in the group after Boydurjo finishes.
Just give me 1 minute.
Boydurjo, how much time would you take to type a sentence?
Sorry, sir. Travel mensuration. Uh, Sensor.
Wait a minute. Pratyasha, open the math book. Pratyasha,
Yes, sir.
open the math book and go to the construction.
Yes, sir. Open.
What are the exercise numbers?
Sir, exercise number 14.1 and 14.2.
Hmm?
Exercise number 14.1 and 14.2.
Size 14.1 and exercise 14.2. Please confirm. No one is leaving the class. Now, both of you have to answer this message. Tag that message and answer it. Pratyasha, you can write. Tag it first. Reply on it. Sir, I have completed and no doubts. Is there any doubt, Pratyasha? Pratyasha.
No, sir. No doubts.
So you have to write. I have completed both of the exercises and no doubts pending.
Yes, sir.
Bojutjo, what about you?
Sir, I have completed both the exercises and there is no doubt from the exercises, but I have a doubt from the higher order thinking skills section of the book.
So write. Sir, I have
Okay.
completed both the exercises and no doubts from exercises, but there are few from hot section. Just right.
Yes, sir.
Am I going to bite you?
No, sir.
Bojutjo, is your father home?
No, sir.
You all have completed puja shopping?
Mm, I
Yes, sir.
haven't gone. I think it is completed or so.
Where is your father right now?
My father, I think, is going towards Bushirhat. He said in the morning that he would go to Chandni Chowk to buy some equipment. I think he has bought them and just going now towards Bushirhat.
And by when he is expected back?
Maybe by tomorrow night, sir, or maybe tomorrow. Maybe.
Okay. Now I'm still waiting for your answer, Bojutjo.
Yes, sir.
Like Pratyasha has tagged that message and written.
Yes, sir.
You can also write, yes sir, I have. You can copy the Pratyasha's message, but I have doubts pending from hot section.
Yes, sir. Done. Done.
Good. Can we discuss the doubt right now? How many doubts you have?
Sir, I have the doubt about the trapezium. And, and another I'm saying, just give me 1 second.
Chalo, we'll discuss it tomorrow then.
Okay, sir.
Keep your doubts handy.
Yes, sir. I will.
How many questions are there?
Sir, 2.
How many doubtful questions are there? You can't.
Sir, 1 and
Don't
2.
you mark that you couldn't do?
Yes, sir. 1 and 3.
Only 2 questions.
Yes, sir.
Okay, I'm ending the meeting now.
Thank you for the class, sir.
Thank you very much
Thank you, sir.
Bye, sir.
for having patience and see you tomorrow
Yes, sir.
at 10 a.m.
Yes.
Thank you, sir.